Hi everyone, this is Alexandra Behar and I'm here with Andrea, Patsy, and Kirstine to discuss our 8th lab in motor learning, discussing the topic of contextual interference. And to help explain this topic, we're using a research study called Contextual Interference in Learning 3 Table Tennis Services to help understand this subject. So to start off our presentation, we wanted to discuss the purpose of this research study that we were interested in discussing. So the initial purpose for this article and experiment was to test a theory that was published in 2013 by Faggy, and basically to test his findings and his thoughts with regards to contextual interference. And by testing these theories, we could see if what he published was supported or not by taking this study in particular to another level. When people do research studies on this topic of contextual interference, normally participants of these studies perform no more than 200 acquisition trials. Therefore, when coming up with a new way of testing contextual interference, this experiment intentionally wanted to test the boundaries of participants by seeing if there was an effect on placing more than 2,400 trials on blocked and random groups within the participants. For this experiment, while participants learned 3 table tennis services, there was a hypothesis provided within the article, and this research study hypothesizes that randomizing trials that apparently deteriorate performance could actually enhance learning. However, on the other hand, by doing these trials in a blocked order, this can actually lead to better performance, yet worse learning intake.
The methods in this experiment included 38 undergrad students, ages ranging from 20 to 23 years old, were split randomly into 2 different contextual interference groups. One was blocked, one was random. All of the subjects within this experiment are novices. They have no prior experience in table tennis whatsoever. So within the groups, they performed 12 sessions. Each session had 20 trials, including pre-test portions, which were conducted in the same manner. How to throw and hit the ball, but these sessions were not random. They were not blocked. They were the same for both groups, so they can get a kind of a baseline of the talent within the groups. Then they went to perform acquisition trials for the skills. The blocked group performed their skills in sequential order, knowing that they would be performing task A, task B, task C. Each task had 4 sessions, obviously because there's 12 altogether, whereas random performed each session within a random order. 1 week later, after the acquisition trials, they were given a 21 trial retention test, both in blocked and random order, meaning that the blocked group had to do a blocked retention test as well as a random order retention test. And the random group had to do a block retention test and a random order retention test as well. To compare the results in both groups, the following equation to the right was used. As you can see, MRE equals sigma, all that, and BVE equals the square root of all that. MRE means mean radial error, and BVE stands for bivariate variable error. These were calculated for all the acquisition trials, the pretest trials, and the retention test trials. So after each test was concluded, the MRE and the BVE were the results that the researchers used to determine how accurate each test was performed. something interesting to see is that the pre-tests that were performed all had about the same results, which are most likely expected due to the fact that pre-test was all done in the same manner. There was no variability between them because it was more like a baseline test and also getting the subjects used to the table tennis. But the MRE and the BBE for the blocked and random sessions, so during the acquisition trial, showed a much larger variability. The block group had a significantly higher accuracy number than the random group. And then for the retention trials, this reigned true once again. The block group had way more accuracy for both the blocked retention test as well as the random retention test in terms of measurable error for both of the orders. These findings show that the blocked order with a high contextual interference is much more beneficial during these early stages of learning, which were relevant here in this experiment because this was early stage of learning. This was a bunch of novices learning table tennis, and it just showed that the blocked order had a much higher accuracy rate and was way more successful for them in learning table tennis and all the tasks that included within this experiment and within that skill.
In conclusion, for this research study, we can see that the hypothesis was supported because blocked practice groups ended up performing much better than randomized practice groups. Also, the hypothesis was supported in that random practice groups did not improve during random retention and were actually worse during blocked retention.
Our experiment will test the effects of contextual interference by attempting to throw flying rings at 3 different distance zones with both blocked and random practice styles. All subjects will start behind a starting point that will be traced with spray chalk. There will be 5 feet, 10 feet, and 15 feet zones. These zones correspond with the amount of feet that the starting point is from the target. The subjects will then be divided into blocked and random practice groups, where they will each complete 15 trials. The block group will complete 15 trials in a row before moving on to the next distance zone. So they'll do all of their trials at 5 feet, then at 10 feet, then at 15 feet from the target. The random group will do 15 trials in a row from random distance zones. There will be a random order that these subjects follow. Next, the scorekeeper will give feedback at the end of each trial. The scorekeeper will give this feedback in the form of the score that the subject got when throwing their flying frisbee. This score will be determined from which section the flying frisbee landed in. Each section is worth 1, 2, or 3 points, and if the subject missed the target completely, they get 0 points. After the practice trials have been completed, an 8-minute on-field break will occur. After the 8-minute break, a retention test will be performed by all subjects. These results will help us analyze the effects of contextual interference on learning how to toss flying rings. The independent variables of this experiment would be the distance that the subject is from the target and the group the subject has been placed in. This group would either be a blocked or random group. This will determine the order in which they perform the experiment. The dependent variable would be the score/performance of the subject on each trial.
For our hypotheses, our group proposes that the blocked practice group will have a higher practice score because of the consistency and distance in the scheduled trials. We think this because of the research reported by Shea and Morgan. In 1979, they found that a random practice group schedule led to poorer performance during practice. This would explain our reasoning that there will be a higher score in the blocked practice group than the random group during the practice trials. For our second hypothesis, our group proposes that the random practice group will have a higher retention score, and we think this because of the contextual interference effect. This effect states a high amount of contextual interference results in better learning of task variations than a low amount. This statement would explain our reasoning that the learner would have retained the skill better with a higher contextual interference from the random practice group rather than the blocked practice group with low interference. So for the demonstration of our experiment, this video demonstrates the overview of what the experiment would look like if we had multiple subjects and a scorekeeper. So just a quick recap, we had 3 different starting points of 5 feet, 10 feet, and 15 feet. and were labeled with spray shock. The block participant performed 15 trials starting at the 5 feet starting point. Once she threw her 5 practice attempts, she then moved to the 10 feet starting point and then to the 15 feet. The random practice participant performed the 15 trials at a random schedule of zones. So the subject could start from the 15 starting point or 5 feet or 10, or mix them up. After the practice trials have been completed, an 8-minute on-field break will occur. After the 8-minute break, a retention test will be performed by the subjects completing 6 trials at a random schedule, 2 for each distance zones. The results will help us analyze the effect of contextual interference on this task.